Hello, good evening. Today we're going to talk about stability and determinacy of a structure. Before we get into details, we have three types of systems: frames, trusses, and simply supported beams. So, what's our aim? Our aim to know or to determine whether the system is stable or determinant. So, to know if the member is determinant or not, we have to compute the value of I. If I equal to 0, then the member is determinant. If I is more, if I is larger or less than 0, then the member or the system is indeterminate. Okay, to determine whether the member is stable or not, here we need to use your imagination. And you need to use your, you can take a section that would help. And if you take the sigma of Fy, then the sigma of Fy is not equaling 0, we can say that the member is unstable, okay? For example, we have simply supported beams, and to check determinacy, we calculate the value of I. And we use this equation, I equal R minus 3. R stands for reactions, and 3 is the type of reactions. What do we mean by the type of reactions? Type of reactions stand for sigma of Y, sigma of X, and sigma of a moment. Okay? A really important note here that if we have a hinge between those supports, this hinge going to get into this equation, going to affect this equation, and by this C. So I equal R minus 3 plus C. If we don't have those two hinges, then this part of the equation disappear. If we have those hinges, then we should get this value of C into this equation. Alright? Now, for a truss system, we have this example. The question is this a stable member or what? The answer is not, because if we have an external force in here, this is going to make a deflection. This is unstable system. How to make it as stable? We can add another member in here which make it a stable member, or if the truss was like this, so those hinges are not on the same line, there would be a stable system. Okay. Okay. Our equation is this: I equal R plus B minus 2J, and R stands for reactions, B stands for members, and J for joints. Let's calculate I for this example. I equal R plus B. How many reactions do we have right now? Okay, we have 3 reactions. Here we go. We have Fx, sigma of X, sigma of Y, and sigma moment. So we have 3 reactions. How many members do we have? 1, 2, 3, 4, 5. We have 5 members. Let's check for joints. We have 3 joints. Okay. And we have little addition to this equation, which is C. So we said that we have 6 reactions plus 5 members minus 2 multiplied by the number of joints, which is 3, plus C, which is 1. Okay? Okay. Now we're going to talk about the last branch of our systems, which is the frame. The general equation of reference is I equal R plus B, 3B minus 3J. And as we said before, R stands for reactions, and B stands for members, and J stands for joints. And we have really important note here. To calculate C, it's equal to members, I mean the number of members. Oh, whoa, I made a mistake, sorry. Members minus 1. Alright, so here's C equal 1. We have 2 members, joints to this joint, and here we have 3 members, which means C equal 2. That's it. Thank you for listening. Bye-bye.